Hey everybody, here's a problem you need to do in the Google Classroom. Alrighty, it's about how big is the gravitational field on a, not the field, the force, my bad, on a satellite. So let's start this thing. All right, guys, so it turns out we're above Venus. Okay, we have a satellite, we're investigating Venus. Now, the mass of this satellite is 1,917 kilograms, and the altitude is 6,021 kilometers above the surface of Venus. So there's some unit conversions we're going to have to do because we need to be in meters if we're going to find a gravitational force on that satellite. And the other thing is that's the altitude, that's the distance above the surface. Remember, to measure gravitational forces, what you need to do for this, you have to go from the center of the satellite to the center of Venus. So I'm also going to have to add the radius of Venus. And here's Venus. There's the mass, which I need to know the mass of this to find the force between the planet Venus and that massive satellite. And the other piece of information I need is the distance. This is almost the same size as the Earth. It's only, its radius is only a teeny bit smaller. Discovery, it's ancient. Distance from the sun. We don't have to know the distance from the sun because we're finding the force not between the satellite and the sun or Venus and the sun. We're looking for the force between the satellite and Venus. So we need the distance between the center of Venus and the satellite. So that's the information we're going to use over there. Okay, so to find out what kind of force is acting between the satellite and Venus, I guess we're going to go in pink here. So remember, we're going to use F equals the big G, mass divided by the radius squared. Okay, so to find that gravitational force, it's the big G thing. So that's the 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. That's just the G. That's the constant. Okay. One mass is the 1917. That's the satellite mass. The other mass is Venus down here. And the mass of Venus is a little smaller than Earth, but not a lot smaller. It's almost the same mass. It's 4.8. I'm just going to call it, well, okay. I have 3 sig figs. I don't know if I need to go beyond 3 sig figs. But the mass of Venus is 4.86. Oh, I should have rounded that. Oh, well, I guess I won't do it to 3. To the positive 24. That's a 2 right there. Kilograms. Okay, that's a 2. Divided by the radius. Okay, now here's what gets complicated because the distance is the center of the satellite to the center of Venus. So I need this distance, which in meters is 6,021 kilometers. I need meters, so I got to go 1, 2, 3 for the meter part. Then I have to add on the radius of Venus because that's the distance center to the center, which is 6,051,800. Okay, now don't forget to square this last little thingy. So I can actually do this in one swoop of my calculator. I just have to be careful of my parentheses and my order and everything. I don't need parentheses for the first one. At 6.67, second function EE, negative 11 times 1917 times 4.86, second function EE, 24 divided by, I need parentheses on this one, parentheses 6,021 and 3 zeros. Got it? Plus 6,051,800 and parentheses. And then I'm going to square this sucker. There it is. Bam, equals 4,264. So 4,264. I only have 3 sig figs, so I'm going to go with the force of attraction of 4,260 newtons. That's my final answer, guys. 4,260. So I'm ready to end this madness and put my name in there. And my force is 4, 2, 6, 0. And it's in Newton, so I'm done and submit. Bam, my answers were good. Oh, they're trying to tell me it's 4,273. They're wrong. They are wrong. It's 4,260. I don't know what they're thinking. I don't know what their major malfunction is, but there you go. All right, good enough for me. Put that in the Google Classroom and we are good. All right. Stopping that share and stopping the recording. Have a good one.